So we're going to do all the examples that we didn't get to on Friday today, and we're going to go back over one we started but didn't finish. So we got a lot of work ahead of us, and today's a tough one. Now, it is nothing new, but it's some tough distance and washer problems. Reed has made you some beautiful visuals that will help, that you'll see on the board. What software did you use? Well, I've never used that one. I've done Win Plot, and it makes the pretty ones. I got a little lazy. So he took care of it. That was pretty visual. Yes. Now pass up your homework. I'll pick those up as we go. Okay, so find the volume of the solid created if the region bounded by the graph the square root of x, y equals 0, and x equals 3. So this region, if we take that and rotate it around the y-axis, so we're spinning around the y-axis. Okay, any questions so far? So we're going to get this shape here, right? We have an outside and an inside. So there's a gap between the region and the y-axis. So what cross-section shape are we going to get? They will be circles. Discs or washers is my question. Washers. Why washers? Because there's a gap in the middle. So I know that I am doing the washer formula. Wait. Why?
Because it's
they're going around a vertical line. Good question so far. As soon as I see this over here, I need to change my equation from the square root of x to
y squared.
Because I've got a dy, I need all y.
Is there like focusing on the drawing just showing that it's rotating down?
Right. Okay. So this should be a little taller. And then so we have our circles. We will have inside circles here and outside circles here, making our washers. What is the radius of the outside circle? Everyone agree? 3? That outside circle is the same all the way up. In fact, my outside shape is a cylinder. Does everyone see that? So 3 squared. Minus the inside radius. That's a little bit more work. Not a ton. But the inside radius would be y squared minus 0, or just y squared. Where am I going to integrate from into? I would if I were x. Well, actually, it would be 0 to 3 if I were x, because you would just do the region.
So how do you do it? Oh, do you need to plug in the x equals 3 into the equation?
You need the y values, right?
Yes.
So 0 to the square root of 3. If you're talking about that x value of 3, that would be a y value of square root of 3. This is one you could do the integration by hand. Y to the 4th, right? 1/5, y to the 5th. We could do all of that. I'm going to move on and just keep setting problems up, but it is one you could work by hand. It'd have a messy answer because of the square root of 3. Any questions about that? Okay. We already did A. There is your visual for A. Second, Chris can read. So you see how that's swinging around the x-axis. It's got it 3-dimensional there. Here, let me turn out one of the lights so you can see that well. Everyone see that? So that's the one, we did that one yesterday, but there's a nice visual of it. And you see how it's rotating around the x-axis, creating it.
Way all the way.
Well, Oh, rotating out towards us. I see.
Yes, rotating out towards you.
Oh, that makes sense.
Gotcha.
Really nice fish. We did that one yesterday, right? We're gonna do. We did the line right side yesterday. I think we did white side yesterday as well. Okay, what we didn't do is y equals -3. So we're going to do y equals -3. Okay, any questions so far? So we're going to take this region, this one right here, and rotate it around the line y equals -3, which creates this region here, right? We've got this spinning around. Again, it's a washer. How do you know that? There's a big gap. I think we did this one. We did one.
Very sad.
There's a big gap between y equals -3 and the region. So as soon as I notice that, I know that I have a dx. Oh, and the washer. Sorry. Why is it dx? I was answering a different question.
Because the horizontal.
Around a horizontal line, right? I am going around, and I don't have my picture drawn very well. This should actually be moved down a little bit. A little better. So we are revolving that around. I need to figure out what is my big R. So I'm going to start looking at the circle that I would create on the outside. Okay.
So these pictures that we're creating, they're like cylinders with like a hole cut out of them. It's
Right. This would be kind of a partial cone.
Plus, gosh.
Because it's got
So a cone and then with the
weird shape inside.
dang, that's weird.
So it's that shape spinning around. So my big radius would be this line minus -3.
What?
That big radius would be this line minus -3. And that line was x plus 2. And you can write +3 minus -3 is +3, so you're welcome to do that. The little radius that makes up my washer, right? This little green circle on the inside. That radius, and I'm going to draw another one just so you don't think it goes up to the x-axis. Right?
So that line is.
Good. So x squared. Okay, if I write +3 minus -3. Top minus bottom gets you that distance. Questions about that?
As long as we're not solving these things.
Good. Well, a lot of them, now some of them will be non-calculator problems, but a lot of them, the non-calculator ones will just be a setup, and the calculator ones will be the ones where they have to find it. Now, occasional ones like the one on the last slide, I said it could have been a non-calculator. These could be, but it would require foiling. A lot of the ones like this will be a setup. They'll have multiple choice on AP exam. They'll have this question and they'll have the answer written in school format on a lot of them. Now I'm not telling you there won't be any with number answers, but okay. This one we started on Friday, but we did not finish, and it is a hard one. So we need to look at it carefully. And Reed's picture is very helpful, and I'll show you that. The one thing you can't see on Reed's picture is kind of the way that it goes this way. It cuts off on that side, and I'll show you that as we go. So we've kind of got this little shape swinging around, and does everyone see it? Yeah, get the light for just a second. We'll turn it right back on. Does everyone see that? Turn both off for just a second. Does everyone see the shape swinging around the line x equals 7? Everyone see it? Perfect. So, this one's really tough. And I'll show you why as we go. First of all, is there a gap? Definitely a gap, right? It's way over here, right? The region's off the screen, right? Way over here.
Wait, so that is this graph x squared?
This is still the same graph, yes.
Okay, so that's touching 0, 0.
It is.
It just looks like it's
Yeah, but it gave us the picture. Really quick, let me go back to this one. Did we put endpoints on this? We need to put endpoints. -1 to 2. We found those yesterday. Does anyone need me to remind you
You would go through that.
It wouldn't hurt.
how we found those?
Yeah.
These intersections, the x squared equals x plus 2. Do you remember us doing that yesterday?
Yes.
And so we get x squared minus x minus 2 equals 0, x minus 2, x plus 1, x is -1 and 2. We did need to find those intersections. Sorry about that. I left that off of this one. -1 and 2 are the x values of the intersections. Now, oops. I'm going around the line x equals 7. So I'm spinning this way. Okay? Now, definitely a washer. Does everyone agree? Big gap. We've got a washer. And what are we integrating with respect to? Y. Definitely dy. Here's the problem. Watch my circles here. So I've got my inside radius. That's not too terrible. Okay, inside radius. Not too terrible. Someone tell me the problem with my outside circle. Someone tell me the problem. Right, there's a problem, isn't there? The radius on that red circle is determined on the bottom by the parabola, but on the top by the line. We are integrating with respect to dy. We're going to need 2 different integrals. Because we have, essentially, we're going to have to break this up into 2 regions. The regions below that intersection and the regions above that intersection. So star this on your notes. It's a tough one. They're not all this tough. I'm going to show you more than one like this. This one's a bad one. In fact, I would say, you're talking the 10% hardest, yes. So these are the really hard ones. You're not going to see a million like this, but you will see some like this. Those of you who go on to Cal 2, you will learn something that's called cylindrical shells that will allow you to only do one integral on this. A little bit different integral. You could learn it now if you wanted to. It would require it on your own. Some years I throw it in with the snow days. I a little bit about doing that, but it's not on the AP.
It's not. Is it the easier way of
There are occasional AP problems that can be a little easier with shells, but sometimes they confuse people on discs. So it's one of those things that it could make it easier. It could also confuse you and mess up some disc problems. So I am going to integrate from 0 to 1. Plus the integral from 1 to that intersection. Well, where is that intersection?
Or x equals 2, y equals.
Very good. 4. If x is 2 and this is x squared, Or if x is 2 and this is x plus 2, then the y value would be 4. So we've got to do two separate integrals. We've got to do the shape on the bottom with the x squared graph, and we've got to do the shape on the top with both graphs. So now let's talk about how to do that. They are both dy, right? Which means what function am I going to need for this blue one? Y minus 2. And what function am I going to need for the red one? X equals the square root of y. Now, plus or minus, right? Sometimes it'll be a plus, sometimes it'll be a minus.
Oh gosh.
It's a tough one. So, capital R, the big radius on the bottom part. The big radius on the bottom part. We're going to go right minus left, right? So we're going to do the right-hand function, which is 7, minus the left-hand function. What is this thing? What is this thing right here? Which one is it? Minus the square root of y. So we're going to do 7 minus negative square root of y. And then 7 inside radius, green, 7 minus 7 minus the square root of y. Okay, let me show you that again. So we're below this intersection, below the yellow line. The red one is 7 minus the left-hand square root of y curve, right? Which is negative square root of y. Everyone see that? The right hand is 7 minus the square root of y, the positive side of the square root of y. You're doing the same parabola, right? One's the right-hand side of the parabola, one's the left-hand side of the parabola. Plus the integral from 1 to 4. Don't forget the pi in front. The top circles, the bigger circle is 7 minus y minus 2. Oops. Minus the little one, which is still 7 minus the square root of y. That piece didn't change from one part to the other. This one's a bad one. That is, again, it's as bad as they get for discs. You had to do 2, or for washers.
So, what is this? I got whenever you're integral, what, like, how
Gives you the volume of solid.
right. But
So you are truly, like, this is, the meaning behind this is finding the volume. The real life application of this example, this is actually one of the things I've used in real life, sort of. My husband had a friend who worked he was a bidder for construction, and he had had enough calculus in high school to be dangerous. You know, he had had a calculus class in high school. And so he knew you could find volumes using this, and he actually brought me, he was trying to bid a job really accurately, because it was a tight job. He wanted to know how much concrete to make this sculpture outside of the front of a building, how much concrete he was going to need. And he gave me the dimensions of the edge, and I was able to use this front volume for it.
okay,
So like really for volume.
this is okay. So this is one of those where if you wanted to, you use it to find the volume of like something if you only have part of the dimension.
No, whole dimensions, but something that you can't say it's a sphere. So it's an irregular shaped object. So we're going to find, later this week, we're going to find the volume of Hershey's Kiss this week.
No, I have no idea what the internet is.
It says 7 minus the square root of y squared. Here, I'll move this away.
And what is the? Oh, it's just a part.
Really integrated respect to why I want to put it in our calculator.
You can type a y if you want. You can type an x. Pretend it's y, it doesn't matter. But you can type y, just alpha 1. But you can, it doesn't matter. Okay, let's look at the next one. Very similar problem, very difficult again. So you get to see another one. It's different, but similar. So I'm showing you two really, really bad ones. The light at the end of the tunnel is knowing they're not all this bad.
So all of these have to do with rotation, but the other ones that we were doing before, where it had specific square cross sections, that would make sense.
Maybe if it's anything that's
Because I don't see like the other ones I can sort of get it if you had because of the cross sections, but I can't imagine like any calculate the volume of any real world object like this.
a Hershey's Kiss.
How much Hershey's Kiss?
But there are a lot of shapes.
So what? We just find the slope of like the edge of the Hershey's Kiss and then rotate it around.
Okay. You write an equation for it, or use Riemann's constant. Got lots of options. And speaking of visuals, I have a washer visual for you to pass around. Kind of shows you what that looks like. So I'm going to pass that around just so you can hold it. Or this. Okay. So have we had time to draw this picture? So we're going 1, 2, 3, 4, 5. Okay. We're doing, remember, this region. And so. If you're saying these are hard because you're not good at drawing them, I'm with you on the drawing part. I'm pretty awful at that. Remember, this part is more for visualization. You can work all of your values off of the right-hand piece. You don't need to draw the left to be able to count values. You can kind of see it, but you don't have to be able to draw it. So, why is this one hard? Same reason. Now, the outside circle, all of the edges of the outside circle are on this piece, right?
Yes.
What about the inside piece? The bottom's on this piece, the y squared, but the top is on the other piece. So this one, it switches outside easy, inside part on this one because we went the other way, right? Makes sense, outside and inside switch because we're rotating on the left-hand side of this figure instead of the right-hand side of the figure, so inside becomes the outside. So we have the inside. Let me draw it a little better for you. We have the inside circles going from the x squared function to the x squared function. And we have the outside circles on the bottom still going from x squared to x squared. Except a different part of it. Does everyone agree? Okay. So I'm going to do my integral from pi, 0 to 1, of the outside radius, and this is still a dy. I didn't explain why it's a dy. Are y'all okay with that part? Why it's dy? 0 to 1 of the outside radius, which would be right-hand curve, which is square root of y, minus the left-hand curve, which is, right, to get the radius, that distance, -5. Y'all okay if I put +5? Minus the inside circle, which is -square root of y plus 5. So that gives us the volume up to this point. So if we were looking at, I'll borrow that for a second. If we were looking at a shape like this one, now this one doesn't have the switch curve, but it would be like we found the volume of these two pieces. We now need to find the volume of these pieces. Does that kind of make sense what we're doing? We found the volume of the bottom. We need to keep going up. So from 1 to 4 let's move up a little bit. Now outside's still the same, isn't it? Oh, thank you. Pi front. Outside still square root of y plus 5 squared. But now the inside curve, I'll do blue this time, is now, right? The right hand piece is questions about that one. Pretty yucky, I know. There would not be a lot of them. Okay, let's look at the next one. Find the volume of the solid if the region enclosed by y equals 2x, y equals the cosine of x, the x-axis is rotated about the line y equals 4. Any questions so far? So I showed you a split on the y-axis. I'm going to show you one split on the x-axis. Now this one didn't draw the picture for me, but this will be a calculator question. Someone tell me why this is a calculator question. Cosine 2x equaling 2x. You all know when cosine of x equals 2x. Do you have any way to find that? No. So that's a calculator question. So I'm going to draw the picture. We have cosine of x, 2x, and the x-axis. So first I found the region. Typical AP problem is going to, open response, is going to say, part A, find the area of region R. Part B, do this to region R. Find the volume if the cross-sections are squares. Part C, revolve the, right, that's how they kind of work AP problems. They make you do several things with that one region. Kind of, yeah, because you'll have already found the intersections on part A, so some things that will help. Right, I'm going to rotate around the line y equals 4.
Did you say we did?
3 or 4. Now, of course, it depends on how you do on multiple choice, right? You know.
But you just need to get like a 4 out of 9.
Remember, you need to get pull that paper out in your syllabus, look at that, and you can see exactly what you need to score total, and you can kind of figure out where you can place your. Right, you probably know by now from my tests whether you're better at open response or multiple choice. So you can kind of tell where those points might fall. Okay, so if I move this up here, right? No, I did that wrong. We've got spotlight on the outside. I don't see it like.
Yes.
Okay, rotating that around. You saw I stink at the drawing part, right? I'm with you there.
That's still wrong because it should be the curve
Curve
is
side,
right.
right side.
The good thing about it
There we go. That's
is you can be bad at that part of the picture and still be fine, because we're going to work off the part we know, right? We're not going to write a new function for that piece up there anyway. Okay, so I'm revolving this around. Someone tell me why this is another hard one. Good. Now, where am I? Which one? Y or DX? DX this time. Right, it's still a washer.
Miss King,
Yes, ma'am.
can you send Alexa Botel to the office, please?
She's in my 6-hour class.
Oh, okay, thank you.
You're welcome. Okay. So if I look my outside radius, what is my outside radius? 4?
Yes. Right?
It's 4, right?
Yes.
Because the outside circle's always, right? I've actually got a cylinder on the outside. Does everyone see that? So that's nice. I'm going to undo that stuff. But then look at the inside radius. Right there it uses the line, the 2x line, and then over here it's cosine curve to cosine curve, right? So I'm going to do 2 separate integrals. The first one from 0 to that intersection.
That intersection.
Store it. It's like 0.450. But you'll need to find it and store it. Remember, don't use 0.450. Use the stored value for that. The outside is 4 squared. On both of them. Right, outside radius is 4 either way, because those outside circles go all the way down to the bottom. Questions so far? Oh yes, there is. And this is an X.
Is that negative 0.450 or is that
It's positive 0.450. And I hope that's right. I'm using memory from first hour. Someone did the intersection in first hour.
I don't know.
What is the question? The 4 is the radius from, like if you look at this outside piece, the radius of that is just this high. 4 minus 0. The inside radius is the top one. On the first part, from 0 to 0.45, it's 4 minus 2x. But then on the second one, it's 4 minus cosine of x. We do need the other intersection. Since I know this is a calculator problem already, you could use the calculator to find it. But could you find out when cosine is 0? In fact, it's pi over 2 from the unit circle, right? So you could do that one without a calculator. Or, like I said, we know it's a calculator problem anyway. Any questions about this one? So your homework is to finish that one. And then this AP packet, we're going to still aim for Thursday on the AP packet because it was a tight stretch to... No, I could always do Thursday. Never mind, I did change that. I said Wednesday originally, right? Do Thursday on the AP packet. You got a day back because of the moving the night. So AP packet due Thursday. Yes, all of these. You don't have to do them all, but 2, 6, 8, 11, 12, 14, 15, and 16. Tomorrow is a work day, so come in ready to work, ask questions. Any questions? We'll do that tomorrow. I might not go I might not video tomorrow. Okay, so it says that integral from 0 to A is 18. What is A?
Wait, what's the
And the packet that you have. This is Thursday.
Okay.
And then the this and washers tomorrow. This and washers due tomorrow. This the one worksheet. This and washers due tomorrow. And then this AP packet. the inside differentiate. Minus 1/3 x from 0 to k. And I would plug in k and I would get k minus 1/3 k cubed. Minus I solve that equation. This is this is 2/3 a equals 18. Multiply by 3 over 2 is 8.